Greetings again, Scott here, known as Cantaloupe to some online, and I am bringing a subject to you today about how to program an interface for WebGL. In a nutshell, this is a framework that sits on top of the OpenGL graphics language. GL stands for graphics language. It's how shaders are programmed to interface with your graphics hardware in your computer or your device. And you pretty much want a framework of some kind, whether that's a browser framework or an application framework like C++ or any of the big languages. They all have bindings and APIs, as it's called, an application programming interface, to use WebGL or some version of it. And it's a way to create graphics in an efficient, streamlined way on your device or your computer. And the way you do that in your browser is through what's called WebGL. And I'm not going to get too technical in this video, but I am going to share a few things that I'm working on in my own project right now that I have going on. It's a framework, as I said, for interfacing with WebGL, similar to something you might have heard of called 3JS. It's an open source project that has a lot of users and a lot of maintainers online. And it's on GitHub. You can browse the code at your leisure, and you can even contribute to the project. And that is kind of why I began this project, is because I decided to start learning 3JS myself, and I got to a point where there was something I wanted to be a little bit different. I thought it would make programming sense to add a feature, so I did what's called a pull request. You can do that with open source software. If you're not familiar, you can fork a repository, any open public repository, make a change to it, and then you create what's called a pull request, which can then be reviewed and merged into the main code base. This is how communities develop open source software. However, I ran into a little bit of a challenge with 3JS having a very rigorous testing requirement. It's good in a lot of ways to have rigorous requirements for integrating code, because you don't want bugs or badly designed code or sloppy code to make it into the main code base. So turns out their code base is pretty it's locked down pretty tight. It uses some very strict linting and some tests and what's called circle integration tests that prevent any kind of unexpected behavior or bad syntax from getting in. But it was so difficult to get in that I decided it would be faster for me to just make my own, basically. So this is just going to cover a couple of things, non-technical details about my own version of what that is. It's a framework for accessing WebGL. It's not actually WebGL, and I'm not going to get too much into WebGL in this video, but I'm going to cover a couple of things that I have done. And you can see on the screen that what I'm describing is the ultimate goal, the effect of what you can do with this stuff. So I began by creating what's I mentioned shaders. If you're familiar with graphics programming, you already know what shaders are. They have in the web universe, there's only two, as far as I know. There's the vertex and the fragment shader, and again, I don't want to get too technical with those, but my framework, my project has an object. It's a kind of a template, if you will. It's just got one shader, one main shader at this time, and I may expand it to include other shaders. But what I'm doing, because you're going to want users to have the option to pull in effects independently, individual effects such as Phong, if you're PHONG, if you've heard of that. It's kind of a fake lighting that you can apply to objects in three-dimensional objects, or reflectivity, whatever. But you want to be able to have them optionally pulled in without a huge cost in terms of memory, or you want things to be fast and efficient, obviously. So the way I'm handling that in my project is I have what described as a template shader, but it's an object. So it accepts optional input in the form of pre-built shaders or components that get injected basically when the user chooses to include them. But at this time, it's not just arbitrary. They can't just give it random code, and nor do I necessarily want them to, in the interest of keeping it super easy to use and having a low barrier to entry for new users, which was honestly an opportunity I saw with Three.js. There was a bit of a steep learning curve, and I'm not trying to be disrespectful to Three.js. It's a great project, but I have a lot of reasons at this time to branch off and do my own thing. So you see, there's super easy ways. The goal is to make it easy for new users and even experienced users to leverage this framework to create video games, to create graphics or what animations, whatever they're looking for, with a small amount of code. So I'm creating what's called an abstraction layer with this API, if you will, or framework, whatever you want to call it. The abstraction layer gives the programmer a great deal of power and control with just a little bit of code and probably a little bit of experience and knowledge. Hopefully, it should be easy and super robust and consistent. And so far, it's going really well with this project. I've been doing it for a little over a week, this particular project, and it's got a few working shaders. It's got some shapes. It's got some modularity. It's set up in a way that I can expand it or scale it, as they say, pretty easily. So not to get too much into it, but that's just a real brief overview. And there will be hopefully another video about this as I continue to develop it. If you have questions or concerns or comments, feel free to email me at whitehotrobot@gmail.com. I thank you for your time and have a great day.